I am Dr. S. Jaipurni, professor in ECE department, and I am working at Sri Shanmuga College of Engineering and Technology. Today we are going to see about thermal testing in VLSI. First, we will see what is this thermal testing. Thermal testing is the process of checking how a system or material behaves under temperature variations. It is used to measure the heat resistance, thermal stability, heat dissipation, and reliability. It is important in electronics, mechanical components, aerospace, automotive, and manufacturing techniques. It ensures product performance under real world temperature conditions. This is the architecture of thermal testing. The architecture of thermal testing consists of a setup that measures how a device behaves under different temperature conditions to ensure reliability and performance. It includes a temperature chamber or heating cooling system that creates controlled thermal environments. Sensors such as thermocouples or infrared sensors to measure temperature and a data acquisition unit to collect and display readings. The device under test, that is DUT, is placed inside the chamber and the system gradually varies temperature to observe changes in performance, stability, and safety. So here we have a heat sink, a heater, an airflow is there, a temperature sensor, a thermal foam, a device which has to be tested is present, and a device socket is here. This is a burn-in circuit board. All these components are present here. So in order to test, what we have to do is we have to give the temperature, that is airflow, give the temperature, and then we can detect the device and we can analyze its performance. So this is a block diagram. So I have a discrete PID controller. PWM refers to the pulse width modulation. Heat chamber, that is, it contains a thermocouple. Then RS-232 interface, which is being given to a PC, that is personal computer. And I have my ADC, that is analog and digital circuit unit. Sorry, analog to digital converter unit, an amplifier, and then a cold point thermometer. So I have a control plane, that is a T reference is already being given to the PID controller. Always a temperature reference has to be given in order to check whether my the desired device under test is working properly. So after the heat is being given in the heat chamber, it is being measured and it's being converted, given to the amplifier and then to an analog to digital converter circuit. I have an RS-232 interface which is being connected to the PC in order to measure the thermal energy. The device is placed in a thermal chamber where controlled heating or cooling is applied. Temperature sensors are attached to measure the heat changes accurately. The temperature is increased, decreased, or cycled based on the test requirements. Performance and stability of the device are observed during the temperature changes. Data is analyzed to identify failures, thermal limits, and to ensure that the device meets safety standards. So these are the various applications of thermal testing, that is ICs, PCBs, power devices, is to check whether it's overheated and reliable. Automotive, that is engine parts, sensors, batteries, and EV components. In aerospace, to check aircraft materials, satellites, high altitude components. In construction and materials, namely insulation, metals, plastics. In consumer products, namely mobile phones, chargers, and home appliances. So advantages. It improves product safety and reliability. It predicts failure points easily. That it ensures compliance with thermal performance standards. Limitations. Testing equipment is expensive. The time consumed for long duration tests. The results may vary depending on the testing environment. So when we test PCBs or some special material, we have to always make sure that the room temperature is maintained constant. And every time when we test, we have to also make sure that the room temperature, suppose if on one day we are testing at 30 degrees centigrade, another day, the next day also when we check the same PCB, we have to make sure that it the room temperature is maintained at 30 degrees centigrade. Otherwise, it will give varied results. Thank you.